Okay, today we're talking about determining the number of solutions. Remember yesterday we talked about how many solutions there could be. We said that you can either have one solution, ultimately many solutions, or no solutions at all. But today we're going to go over on how to determine which of those cases we'll have. And to do that, we're going to look at these problems on the board here. We have Yari and her friends, Alyssa and David, are each given an equation to solve. Yari's equation is 2 times the quantity x plus 10 minus 17 equal 5 plus 2x minus 2. Alyssa's equation is 5x plus 3 minus 3x is equal to 2 times the quantity x plus 3 minus 5. And David is given an equation of 2 times the quantity x minus 3 plus 9 is equal to 5 plus x minus 1. Whose equation has only one solution? Whose has infinite many solutions, and whose has no solution? We're going to go through and look at each one of these to determine that. We're going to start with Yari's equation. Yari's equation was 2 times quantity x plus 10 minus 17 equal 5 plus 2x. So the first thing we have to do is distribute the 2 to both terms, and we end up with 2x plus 20 minus 17 equal 3 plus 2x. Then we'll collect like terms, and we have 2x, and then 20 and 17 are like terms. So we have plus 20 and minus 17, which is going to give us 3. So we end up with 2x plus 3, and on here, our like terms are 5 and negative 2, which gives us 3. Now, these two expressions on either side of the equal sign are equivalent to each other. They're just written in the reverse order, so they're like mirror images of each other. 2x plus 3 is equal to 3 plus 2x. And since we know that addition is commutative, we know that those are equal to each other. So anytime you have the exact same thing on both sides of the equation, where your variable terms and your constant terms are exactly the same, you're going to have infinitely many solutions, because no matter what you put in there, you're going to have the same, you're going to get the same answer on both sides. If we subtracted 3 from both sides, we would have 2x equal 2x, and for any value of x you put in there, you multiply it by 2, you're going to get the same answer. Okay, so that one has infinitely many solutions. All right? Let's take a look now at Alyssa's equation. Her equation was 5x plus 3 minus 3x is equal to 2 times the quantity x plus 3 minus 5. Again, we distribute to both sides, right here and right here, and we end up with 2x plus 6 minus 5 on this side, and again over here we have 2x plus 3. When we combine like terms, we have plus 6 and negative 5. That's going to give us plus 1. So now we have 2x plus 3 is equal to 2x plus 1. And if you think about this in the form of a linear equation, if the variable is the same, has the same variable and the same coefficient, and the constants are different, those two can never be balanced. Right? There's no number that you can put in and multiply x, times x. No value of x you can put in, multiply by 2, and add 3 and add 1 to that same number and get an equality. So this equation is going to be slanted to the heavier side of the 3. So for this type of equation where you have the same variable, the same coefficient, and different constants, you can never have a solution. So there's no value of x that you can put in and have that solution. If you look at the third one, which is David's equation, we have 2 times the quantity x minus 3 plus 9 is equal to 5 plus x minus 1. Again, when we distribute, we get 2x minus 6 plus 9 equals 4 plus x. When we combine like terms up here, 5 and negative 1 add up to 4. So we have 2x plus 3 equal to 4 plus x. As long as these x values are different, we will always be able to have one solution. And to show you how that works, what we'll do is we'll go ahead and take the 3 from both sides. We'll put -3 on both sides. And we end up with 2x equal, equal 1, right, plus x. Then we'll take that x from this side, -x, and I get x is equal to 1. So my value for that is x equals 1. There's one solution. So anytime you have different x's, it doesn't matter what the constant is, as long as you have different x's, you're going to have one solution. So let's take a look at the back side and let's discuss these a little bit further. So when we looked at the model for Yari's equation, what did we notice about both sides of the equation? Well, we noticed that both sides were exactly the same once we simplified. So we simplified them to the exact same thing, right? So when they simplified, both sides simplified to 2x plus 3, all right? All right. And if we subtract 2x from both sides, actually it would be 2x plus 3 on both sides. If we took 2x from both sides, we end up with 3 equal 3, and that's a true statement. Anytime you get a true statement, exactly one number equal to another, one variable the same, x equal x, 3 equal 3, 2 equal 2, it doesn't matter what it is. That true statement means that you have multiple solutions, right? Then we look at Alyssa's equation, and they want to know how's Alyssa's equation different. Well, if you remember Alyssa's equation, it came to 2x plus 3 equals 2x minus 1. I believe it was minus 1, plus 1. All right? So how's it similar? Well, how's it different first? It's different in that the constant values are different, right? So the constant values are different. And the x values, the variable values, are the same. All right, and because of that, we know that we have no solution on this one. All right, now when we look at the pan balance, when you look at your previous page, look how the pans are balanced. Is there any way that we could balance those pans? The answer to that is no. No, because at this point right here, we have 2x plus 3. So we have 2x plus 3 equal 2x plus 1. They said, what happens if we subtract 2 from both sides? 2x from both sides? So we take 2x from both sides. That's an equal sign. It's not a good one. We get 3 is equal to 1, and we know that's not true. That's a not true statement. Anytime you have a statement that is not true, then we have no solution, right? So there's no solution to this problem, right? All right, so we're going to move this up, and we're going to have to erase this to do so, all right? So let's look at David's equation. Are the variable terms on each side of the equation the same or different? Well, we saw that the variables were different. The variables were different. And if we solve David's equation, it ended up being, we got down to 2x plus 3 equal 4 plus x. And we solved it on the first page anyways, but we'll do it again right here. So we'll take x from this side. We'll get x plus 3 is equal to 4. Take 3 from both sides and get x is equal to positive 1. All right, so here x is equal to 1. That's our solution. All right, it's going to have only one solution. Right? One solution. So now they're asking us, how do we know when an equation has only one solution, no solutions or infinite many solutions, and it's all about the variable and the constant. So for no solution, right? The variables are the same. The constants are different. All right? For multiple solutions, many solutions, variables and constants are exactly the same. Exactly the same. And for one solution, the variable are different, and the constant really doesn't matter. Don't matter. All right. So let's one more time. No solution. The variables are the same, and the constants are different. If you were drawing a line, it would look just like that. It'd be just a parallel line. All right. Many solutions, the variables and the constants are exactly the same on both sides. In one solution, the variables are different and the constants don't matter. All right. So what we're going to do is take a look at the triad section, and they want us to have this equation, cx plus d equal 8x plus 12, and they want us to substitute values in and see what we get. So for this, the first one says c is equal to 6 and d is 34, right? Right? C is 36 and d is 34. So if I do c, I do 6x plus 34 equal 8x plus 12, right? So if I do that and I do my on both, I have different x's, right? And I have different values for my thing. So that's going to have the different x is going to give me one solution, right? Now if I put an 8 in there for c, I get 8x plus 6, right, equal 8x plus 12. Here I have the same variable but a different constant, so I have no solutions. All right, so feel free to run this video back and forth as much as you need to get your workbook filled out. And then your homework for tonight is page 151 and 152. And I will be in here tomorrow to check that with you. And you have a great day.